Hey guys, how you doing? Today we're gonna learn something pretty useful about derivatives, and that is how we can take the derivative of a logarithm. It's pretty simple, the same way that you have the power rule or the chain rule, we also have a rule for taking the derivative of a logarithm. It's pretty simple. You just need to memorize it. You can derive it if you wanna give it some personal meaning or some intuition, you can derive it using the derivative definition. But today I'm just gonna show you the rule and we're gonna do some examples, okay? So you know how to use it when you have to. So let's begin. What if we said we have the following statement or problem? We want to take the derivative of log a b. Okay? If you have this, what do you do? Now, one thing you can try, and you're basically gonna use the rule here, is gonna be the following. You're gonna find b. In this case, remember you have log in base a of b. You're gonna grab b and you're gonna take the derivative of b first. So you have b prime over, now you're going to divide by b, normal b, the undifferentiated b. You're not going to take the derivative of b, nothing. You're just gonna write b times the natural log of a, the only number that you have not used yet. Okay? This is the rule that you need to know. If it's hard for you to memorize it, just see it like this. On the left side, if you go like in a, like if you draw a line like this, you're gonna have all the b's. You have b prime and then b, and they draw a line like this. And then you also have one number that you have not used yet, which is gonna be a. And since we're playing with logarithms, just remember that you need to take ln a, okay? B prime over b times ln a. That's the rule that you need to know. And with this, you can solve a lot of logarithm problems. So now let's try that. Let's do some problems. So let's try the following, something simple. The derivative, that's supposed to be a d. I know it sucks, but yeah, it's a d. I need to improve my d's, yeah. So let's say we have d over dx for the function log base 10 for 3x squared. How much is this? Well, we need to find b first. We know b is going to be 3x squared. So we need to take b prime. B prime for b equals 3x squared is going to be 6x. Just using the power rule. Now you're going to multiply by b, which is 3x squared. And you're going to do that in the denominator. And now you want to take the natural log of a. And a is equal to 10. ln 10, okay? This is the derivative that you would have, and of course, you can simplify that. In this case, you're gonna have 2 in the top over x, x ln 10, okay? This is how much you get. This would be the derivative that you are looking for. Nice. Now let's try another problem. What is the derivative with respect to x for the function log base, let's say 6 of 10x squared plus e to the x? Okay, how do you solve this? Now this is it's simple, it's the same. You just need to differentiate each term. So b is going to be equal to these two terms. B prime, let's take the derivative of this binomial. So the derivative of this using the power rule, we know it's going to be 20x plus the derivative of e to the x, we know is just going to be e to the x. So we have e to the x over. Now we need b. Don't differentiate b, just normal b. So we're going to have 10x squared plus e to the x times the natural log of the only number that you have not used yet, which is 6. So ln 6, okay? This is a constant that you have. Now I believe you could do some things here. Maybe you could probably simplify something with the ln maybe, but you can just leave it like this too, okay? Now let's try another example. What if we wanted to find d? This is a d. I need to make my d's better. d over dx for log. Let's say log. I want to show you something pretty cool now that we're gonna do this problem. What if you wanted to find the derivative of ln x, of ln x, using this rule. So basically, what if you said that you have log base e, which is just going to be natural logarithm, but you can also use this notation, and you're going to see what I mean, ln e of x, okay? This, we know it should be equal to the derivative with respect to x for ln x, okay? Now, you already know the rule, well, you already know what this is going to be equal to. This is going to be 1 over x, right? But why is that true? Well, you can grab this one, and something you can do is the following. We know b is going to be x, okay? So b prime is going to be 1. I'm going to write it again here. D over dx for log base e of x is going to be x prime, which is going to be 1 over b, which is going to be x again, times the natural log of e. Okay? And you can see now what happens. This is the ln e is just going to be 1. So you know this is just going to be 1 over x times 1. You basically just get 1 over x, okay? Which is exactly the same rule that you have down here, okay? This is something pretty useful, and I think it shows you how cohesive and well, it's consistent all the math that you've been learning in calculus, okay? You can use different rules to get to the same number, okay? In this case, you can use this rule to get to 1 over x for log ln x, or you could also use that, well, ln x is just going to be equal to 1 over x, always, and that's it. Or x prime over, and that's also another one that I want to show you. Well, it's almost the same, but maybe it's different notation. Another rule that you have is that the derivative of x, well, with respect to x of ln x is going to be equal to x prime over x. And you can see that this is exactly the same rule that we have here. In this case, you could say ln b, the derivative of ln b is going to be b prime over b, and here you could write times ln, the base of, well, a, ln a, but since a is equal to e, we would have ln e, okay? And this is just going to be 1. And you get that ln x is equal to x prime over x, which is the same as if you had that, well, logarithm where log a, where a is equal to e, and then of b. So you take b prime over b, which is exactly the same as x prime over x. I think this is pretty cool, you know, when you use different rules and you get to the same number. It just shows you how cohesive and consistent, as I said before, is math, and that's really amazing. So, well, I think this is gonna be everything for this video. I hope you learned something. You just need to memorize this rule once again, and I hope you enjoyed it. So see you in the following video. Don't forget to smash the like button, and bye bye.